So today's our topic is the tension. Okay. So as you guys all know that our previous topic was the Newton laws. Now the topic is the tension. So what is tension? Tension is the force extended on a body with the help of a string is called tension. What does it mean? It, for example, we are having a body with a string, and here you can say that the tension will be applied on this body. Tension is what? This is a force in actually, and it is a vector quantity because it is having magnitude and direction both. And this SI unit is Newton, as you guys all know, and this their direction will away from point of contact. What does it mean? It means that if we are having a direction that is downward, as you guys see that the weight is in the downward, so this is what, this is the point of contact that is downward. Okay, and we are having a tension. You can say that we are having a tension that is this. So tension is what? It is a basically it is a force. Okay, so the force that is extending on a body, that is the tension. So here you can say that the you can say that the weight is having a direction downward, but tension is upward. Okay, so we can write here the tension is upward. And if you're talking about a body that is a body A, next example, this is body B. Okay, so here you can see this body is having a point of contact downward. Okay, they are having a point of contact downward, sorry, they are having point of contact downward because the body is in the downward side. But if you're talking about tension, so tension is upward because the force is extended on a two body, that is called tension. So the force is extended, that's why this is the direction of the, you can say that this is up, this is upward, sorry, upward, it would be upward. Okay, this is upward. Let me discuss one more, that is this is body A. Okay, the point of contact of this body weight is, you can say this is downward. But if you're talking about tension, that is extended on this mass, so that is upward. So that is the tension. Okay, so if the weight is equal to the tension, so that is the rest body. Okay, this is the main thing. And if the weight is less than tension, so the body will move up downward. How? Because you can say that the if the you can say that weight is, you can say that weight is less of this body and tension is, and the force of the tension is more on this body, so the body will become downward. Okay, why? Because the body is having a less, you can say that weight, that's why. And if you're talking about the tension, if the tension is great, or you can say the greater, so if the, you can say that if the weight is less and tension is greater, so the body will become upward. Here you can see that this body is having less weight. If for example this body is having less weight, so if the force is more extended on this body, so the direction of the body will become upward. And if the tension is less and the weight of the body is too much, so the body will move downward. Okay, so there is more two cases of the tension. So in this video we'll be discussing about one case only. So the first case is that when two bodies move vertically, okay, so that consider a body A and B. Consider a body A, this is B body and this is A body, okay, that is connected by the string passes over frictionless pulley. What does it mean? It means that it is you can say that this is connected with the string and which is over the frictionless pulley. This is a frictionless pulley, okay. So we are having a, as you can see that the weight of the number one is that the weight is downward. The weight of the body A is downward. Weight is downward. If you're talking about tension, so the mass 2 is having a more tension and mass 1 is having less tension, so mass 2 is having more tension. As you can see that tension is equal to upward, okay. And if you're talking about the net force on the body, so here you can see that the net force, first of all let me discuss about what is net force. For example, here we are having a body that is having a, you can say that 10 Newton force is exerting on this side and this side is also having of 10 Newton, and this force is you can say that appeared on the body. So if you're talking about the resultant force, so resultant force is equal to what we add the forces, so they will be 20. If you're talking about net force will become 0. How? Because this will cut to this side. For example, I'm giving you next example of the net force, that is if there is a body, there is the force that is 10 Newton on this body, and here from here side this is 15 Newton, and from here side this is 20 Newton, and from this side this we are having 5 Newton. So if you're talking about the resultant force, so you can sum all these and the answer will become 50. But if you're talking about net force, so here we are having 10 here and 5 here. So as you guys all know, in the net force, we from the greater value we minus the less value. So we are having 15 here, 10 here, so 15 minus 5 is equal to 15 minus 10 is equal to 5, plus 20 minus 55 is equal to 15 is equal to 20. So here you can see the net force is 20. So I can write here that the weight minus tension, because weight is more and tension is less of the body A. Weight is more, tension is less, so I can write that the weight minus tension. And we can also write here that if there is a force, so we can also write, as you guys all know, F is equal to ma. So I can write here that m1a, mass 1a, and m1g, the weight is equal to mg. So I can write here the m1g is equal to mv is equal to w is equal to m1g, okay, and minus t as it is. So if you're talking about body B, so the weight will be is downward. Weight is downward, and you can say that tension is upward. As you can see that the tension of a body is upward, and as you can see that the tension is more, then of course the weight of the body is too much less, so it is downward. So I can write here that net force is equal to T minus V, because here the tension is more and weight is less, but here you can see that in body A the weight was more and tension was less. So M2A I can write here because F is equal to MA, so this is about talking about the M2 body and this was M1 body. So M2A is equal to the T minus M2G, T here and W is equal to mg. So this is equation second and this is equation first. To find the value of the, you can say that A, then we have to add the equation. So we are having m1a plus m2a, m1a and m2a is equal to m1g minus t, m1g minus t, and equation second is the plus t minus m2g. Here the t will cancel, and we are getting common from these. Also common from them is a, so a is a bracket m1 and m2 is equal to mg minus m2g, m1g minus m2g. Okay, so we can write here that this is the m1g and minus m2g. Okay, so here you can see that we have to find the acceleration. So here the acceleration is equal to m1 plus m2, okay, upon, you can say that m1 plus m2 multiplied by g. This is the value of the acceleration. How? A is equal to an m plus m2 and m1 plus, here we have getting the g common here, that's why this is multiplying, and a here from here, and these both get divided. No, this is the minus sign. Okay, one is minus, one is positive. So to find the tension, we have to divide both equation divide. Okay, so we are having an equation that is m1a is equal to m1g, m1a and m2a, and m1g minus t and t minus m2g. These both are the equation that of the body A and body B. Okay, so we can cut A or A. Okay, so this is m1 m2 is equal to m1g minus t upon t minus m2g dv. This is same. Okay, as you guys all know, the cross multiplication will be there. So m1 t minus m2g is equal to m2 m1g minus t. Okay, so m1 multiplied by t, so that is m1t, minus m1 is multiplied with m2g, that is m1 m2g. Here m2 is multiplying with this, so m2 m1g, m2 is multiplying with this, and m2 is multiplying with t, so we can write m2t. Okay, so here we can we can write here m1t minus m2t is equal to m1 m2g plus m1 m2g. Okay, this we have written here, and this we are written here. So we can, if you are getting common from these all, that is t, so t is equal to m1 m2, okay, is equal to, we are having these two values, so 2 m1 m2 and g common from them. So we can write here that t is equal to 2 m1 m2, because we are having two values, that is, first one is the 2 m1 m2, this is here, and next is m1 m2 multiplied by g, not multiplied by, we will simple right here g. So this is the value of the tension. To find the, this is the division of the tension. To find the tension, the equation is this. Okay, so this is the equation to find the tension, and for the acceleration we are having a equation that was a is equal to m1 minus m2 upon m1 plus m2 multiplied by g. So that was all about the tension, and we are done today. We are done with the first case. In the second video we'll be talking about the second case.